On the bottom we get an x plus 3 and an x minus 2, which looks healthy at first, but then when we go to put the 2 in here, this expression is 1 over x minus 2, when we put the 2 in here, we get 1 over 0. So that's mathematically impossible. So we've got to think of something else. So the only thing that I could think of in this, at this point, is to do a chart. So a SISTI chart comes out, and we're going to pick values of x that approach 2. And let's change this problem to x approaches 2 from the left. So that would be, we go 1, and I think I got a negative 1 when I did that. And I'm putting that in the original problem. When I put in a 1.5, see, I'm getting closer to 2 coming from the left. So when I put in a 1.5, I got, let's say 1.5 minus 2 is 1/2. Yeah, I put it in over here. I don't know. I can't read my writing. I got something. Then 1.9, I got negative 100. When I put in a 1.999, I got negative 1,000. So I could tell that it is approaching negative infinity from the left. So negative infinity is that limit, and sometimes we pull out a SISTI chart to help us with those. There are some algebraic, trigonometric limits that I recall. The limit as x approaches 0 of sine x over x is 1. And we recall we went through an actual proof of that using the Squeeze Theorem. And this is true with radian measures. And there was another one that didn't come out to play as much. I'm not sure, positively sure I got this right. If you would check in your comp books on that spot about limits, this is what's in my brain. I think it's right. I know it has something with cosine. I know it was 0. So check that out for me. All right, so this is the one that most of the problems revolve around. So a lot of times you'll see this little trick. They'll say, what's the limit as x approaches 0 of sine of 3x over x? And that is not this, because this says it's the sine of something divided by that same something. So for us to use this has to be the same as this. So the only way I can do that is to multiply by 3 over 3. That doesn't change this argument. So the 3 goes out in front. 3 sine of 3x over 3x. So now these are the same. So this whole thing is just a big fat 1. And we get 3 times 1. That's 3. All right, another one that comes around. It's sort of the same strategy. I remember one or two in our homeworks. What is the limit as x approaches 0? So somehow I'm going to use that limit that is sine x over x. So how could I get that to help us here? Well, I'm going to split the numerator from the denominator. So I'm going to divide this by x and this by x. That's like multiplying by 1 over x divided by 1 over x, which is a big 1. So now I'm closer to this. So this on the top I'll multiply by 5 over 5, and this 4 over 4. So similar in part to the last one, the 5 comes out in front. So we have 5 times 1 on the top. And similarly, you'll see it's going to be a 4 on the bottom. So 5/4 turns out to be the answer to that. Also, I'll make mention that if this equals 1, so does the reciprocal. Sometimes they like to give you expressions that look like that. So you can, if this equals 1, you can assume this does as well. Now, are there any other groups of limits? I know. In the middle of a limit, sometimes in a trigonometric one, you'll find tangent of x. You almost always need to switch it to sine x over cosine x. Not every time, but keep that in mind. And they also, in the middle of your limits, like to use this expression, or this ID, and it usually appears in one of its other forms. They'll put that in, and you should substitute sine, or they'll put this in, and you should substitute cosine squared. Sine squared, I meant. All right, so recall that these are different renditions of this. All right, and last but not least, there is the definition of a derivative, which is a limit, and that is the limit as h approaches 0 of f of x plus h minus f of x divided by h, la la la. All right, so here is the definition of a derivative, and sometimes they will use it, and it looks like a regular limit problem, but you got to recognize this pattern. For example, suppose I have the limit as h approaches 0 of, what can we do? All right. Would you be able to recognize that that is the definition of a derivative? So this is the derivative of f prime of x. So here we have the x plus h minus the f of x divided by h. So what is the function? It's easy to find because f of x is sitting right there when it's in this form. So that's the function. But this is the derivative of that function. So it's really just 2x. So they wanted to know the limit as h approaches 0 of this, and it is just 2x. There's no h in that expression, so that is your answer. All right. I'm trying to think if there's any other major groups of limits. I'm sure as we do our problems, some others will come up, but I just wanted to pull together some of those unusual limits that we used to be able to take and bring them back to mind. So hopefully you'll find this helpful when you go to do your worksheet. All right, sorry about the delay on this one, and we'll catch up. Till then, bye.